Good morning, students. Our today's topic in the subject of Statistics 1 A levels is permutation and combination. So concentrate yourself in this chapter. This chapter is about numbers of the arrangements of different objects and the number of the ways you can choose different objects. So, number of the arrangements and the number of the ways you can choose different objects is called permutation and combination. When you have completed it, you should know what a permutation is and be able to calculate with permutations. Know what a combination is and be able to calculate with combinations. Be able to apply permutations and combinations to probability. So concentrate yourself. We are going to start now. The first thing that we are going to read is permutations. So concentrate yourself. It is useful to start with an easier situation. Suppose that you have the three letters A, B, and C, one on each of the three separate cards, and that you are going to arrange them in a line to form words. How many three-letter words are there? So this thing is easier to understand with the help of a tree diagram. So concentrate yourself. You can show the possible choices by using a tree diagram as in figure 5.1. Now you have three choices for the first letters because there are three letters A, B, and C which are written on cards, and you are required to form three-letter words. So for the first letter there are three choices, and when first choice is done, definitely there will be two letters left. So suppose if A is chosen, so then B and C will be left for the second letters, and if B is chosen for the second letter, then C will be left for the third letter. So the word will be A, B, and C. Likewise, if A is chosen for the first letter and C is chosen for the second letter, definitely B will be left for the third letter. So look now, first letter, second letter, and third letter. So A, C, B will be the three-letter words. Likewise, if B is chosen for the first, C is chosen for the second, and A will be left for the third. So B, C, A. Likewise, if B is for the first, A is for the second, then C will be left for the third. So B, A, C will be the three-letter word. Likewise, if C for the first, A for the second, then B will be for the third. So C, A, B will be the three-letter words. And then if C is for the first, B is for the second, and then A will be left for the third. So C, B, A will be the three-letter word. So it means 1, 2, 3, 4, 5, 6 letters can be made with the help of the three letters A, B, C, which are written on three card paper. So look now, you have three choices for the first letter, that is A, B, C. Having chosen the first letter, you then have just two choices for the second letter, and having chosen for the first two letters, you then have, so this is simple the explanation which I have told you. So these are six letters which can be made. So mathematically we can derive a formula. So look now, so altogether there are 3 into 2 into 1 is equal to 6 possible words you can make with the three letters. And how this formula is made, so concentrate yourself. There were three choices for the first letter, then two choices left for the second letter, and one choice was left for the third letter. So that's why 3 into 2 into 1. So 3 2s are 6 and 6 1s are 6 is equal to 6 possible words you can make with three letters. So the formula which we have derived, that if there are three letters and we are required to form three-letter words, the formula is three choices for the first letter, so 3, then two choices left for the second letter, so 3 into 2, and one choice is left for the third letter, so 3 into 2 into 1. So this is a formula which is derived in the previous example. So look now, you are given 4 letters which are written on the card, and you are required to form 4-letter words. So look now, using a similar argument, you can find the number of the words which you can make from the four letters A, B, C, and D. So look now, here is the answer. So four choices will be there for the first letter, then three choices will be there for the second letter, then two choices will be there for the third letter, and one choice will be there for the fourth letter. So 4 into 3 into 2 into 1. So 4 3s are 12. 12 2s are 24. 24 1s are 24. So 24 possible words will be there. So you can now generalize this result to the case where there are n distinct letters. So when you arrange n distinct letters in a line, the number of the different words you can make is n into n minus 1 into n minus 2 up to so on. So 2 into 1. The different arrangements of the objects are called permutations. The expression n into n minus 1 into n minus 2 up to so on into 2 into 1 is called n factorial and written as n one line and dot. So that sign is for the factorial. So this is called n factorial. The number of the permutations of n distinct objects is n factorial, where n factorial is equal to n into n minus 1 into n minus 2 into up to so on into 2 into 1. So this is called n factorial. The number of the permutations of four letters chosen from seven letters, that is the number of the four letter words, is therefore, so definitely you are required to form as many as possible four letter words from the seven letters. So there will be seven choices for the first letter, then six choices for the second letter, then five choices for the third letter, and four choices for the fourth letter. So 7 into 6 into 5 into 4 will be the answer when you are required to form four letter words from seven letters. So I'm going to tell you a very systematic formula now for the permutations. So this answer 7 into 6 into 5 into 4 can be obtained from. So look now, this is the general formula of the permutation. N is the total number of the objects and R is the thing which are taken out of the total to make different type of the arrangements. So look now, the number NPR of different permutations of R objects which can be made from n distinct objects. So n is the total number of the distinct objects and R objects are going to be arranged. So it is given by NPR is equal to n factorial over n minus R factorial. So look now, total objects which were given in the previous example was, in this example was 7. So 7 factorial over n minus R. So 7 minus 4 because four letter words are required to make. So 7 factorial over 7 minus 4 factorial. So on some calculators, this is written as NPR. So look at the screen on the top, that is given 7 into 6 into 5 into 4. So when you will solve it on the calculator, it will give you an answer of 840. And how permutation can be solved on the calculator, I'm going to tell you. So look now, here is the screen. So actually that is 7P4. So look now how to solve 7P4. So here is 7. So you will have to press 7 first. So look now at the screen, there is 7. Then shift will be pressed. Here is shift. And on the multiplication button, you can see here is NPR. So you will press now. So now on the screen, you can see P. P stands for permutation. And then you will press 4. So here is 4. So look now on the screen, you can see 7P4 can be seen. And now you will press equal button. This is equal. So on the screen, you can see 840 is the answer. Here is another question. Eight runners are hoping to take part in a race, but the track has only 6 lanes. In how many ways can 6 of the 8 runners be assigned to lanes? So look now, the number of the permutation is 8p6 because 8 are the total number of the runners and 6 are to be chosen. So 8p6. So the method to solve 8p6 is 8 factorial over 8 minus 6 factorial. So 8 factorial will over 8 minus 6 will be 2 factorial. So 8 factorial will be solved to put in the numerator and 2 factorials are solved to be put in the denominator. And you will solve this value, that will give you answer 20,160. So these are the number of the ways you can choose 6 runners out of the 8 runners to give them assigned to lanes. Here is a question that involves permutation with probability. So look now, 8 people A, B, C, D, E, F, G, H are arranged randomly in a line. What is the probability? So look now, probability that A and B are next to each other. So concentrate yourself. A part, there is a neat trick which helps to solve this problem. Imagine that A and B are stuck together in the order A and B. Okay, order is AB. So they are stuck together because it is the condition that A and B are next to each other. So if they are stuck together, there will be then 7 factorial ways to arrange the people in the line, because they are considered to be one unit now because they are stuck together in the order AB. So total are 8. So if they are stuck together, there will be remaining 6 other than this pair. So in total, there will be 7 factorial ways to arrange the people in the line. But at the same time, there are also another 7 factorial ways to arrange them if A and B are stuck together in the order BA. So first, they are arranged in AB. So there will be 7 factorial ways to arrange the people. But if the A and B are next to each other in the order BA, so again there will be 7 factorial ways to arrange the people. So it means there are therefore 2 times of the 7 factorial ways of arranging the 8 people in the line with A and B next to each other. So this is the favorable outcome, but the probabilities formula is favorable outcomes over total outcomes. So in total there are 8 people. So it means 8 factorial will be the total number of the ways to arrange the 8 people. So 8 factorial will be put in the denominator because the formula is of the required probability is favorable outcomes over total outcomes. So 2 into 7 factorial are the favorable outcomes over 8 factorial is the total outcomes. Because look now, however, there are 8 factorial ways of arranging the 8 people in the line if there are no restrictions. Okay, the final thing is very easy. Now you will solve it on the calculator and you will get the answer 1/4. The B part is A and B are not next to each other. So look now, we will use our simple rule of the probability that if A and B are next to each other and the answer is 1/4, then the probability of A and B are not together will be 1 minus probability of A and B are together. So 1 minus 1/4 will be equal to 3/4. So this is the simple answer of the B part. So concentrate yourself. We are going to read another very important concept of the permutation. So when there are identical objects present in a group of the objects, so then the method to solve permutation is, so look now, the number of the distinct permutations of n objects. So n objects are the total objects of which p are identical to each other, and then q of the remainder are identical to each other, and then r of the remainder are identical to each other, and so on. So the formula will be n factorial over p factorial. So the thing which are identical, p factorial, then q were identical, so q factorial, then r were identical, so r factorial and up to so on. So from where p plus q plus r plus up to so on should be equal to n. So this formula will be used when identical objects will be present in a group. So concentrate yourself. We are going to solve the questions from this concept. So here is a question from the concept. So look now, find the number of the distinct permutations of the letters of the word Mississippi. So here is a combination of the, here are a number of the words. So look now, the number of the letters is 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the number of the letters is 11, of which you can see 4 are S. So 2 and 2, 4 are S, 4 I's. So 1, 2, 3 and 4 I's, 2 P's you can see here, and 1 M. But first we have to calculate either these total numbers make the total of the letters or not. So look now, 4 plus 4, 8, plus 2, 10, plus 1, 11. Yes, so these the sum of these letters makes the total number of the letters in the word. So now we can proceed forward. So look now, the number of the distinct permutations of the letter is therefore. So in the numerator, we will take the factorial of the total number of the letters, that are 11. So 11 factorial over. Now 4 identical letters of the S are there, so 4 factorial. Then 4 identical letters of I's are there, so 4 factorial. Then 2 identical letters of P are there, so 2 factorial. And 1 letter of M is there, so 1 factorial. So when you will solve it on the calculator, you will get the answer 34,650. The next thing that we are going to read in the lecture is combinations. So concentrate yourself, combinations. When a selection is made from a set of the objects and the order of the selection is unimportant, it is called combination. So concentrate yourself in this kind of the arrangement, that is called combination. The order of the selection will be unimportant, whereas in the permutation, order of the selection was important. So this is the big difference between permutations and combinations. In permutations, order of the arrangement is important, and in combinations, order of the arrangement is not important. So a combination is a selection in which the order of the objects selected is unimportant. The number of the different combinations of our objects selected from n distinct objects is NCR, where NCR will be equal to n factorial over n minus r factorial into r factorial. So this is the difference between permutation and combination. This r factorial makes the difference. So look now again, NCR will be equal to n factorial over n minus r factorial into r factorial. Here is a question. So concentrate yourself. The main problem in this topic is you have to decide either this question is of permutations or combinations. So look now, here is a question in which now you have to decide either this question is of permutations or combinations. So look now, the manager of a football team has a squad of 16 players. He needs to choose 11 to play in a match. How many possible teams can be chosen? So look now, here is the explanation that will make your concepts clear. Either this question is of the permutations or combinations. So this is the thinking process. So look now, this example is not entirely realistic because players will not be equally capable of playing in every position, but it does show how many possible teams there are. It is important to decide whether this question is about permutations or combinations. Clearly, the important issue here is the people in the team and not their order of the selection. Therefore, this question is about combinations rather than permutations. So people are important. Their order is not important. So that's why order is not important. So we have to choose 11 players out of the 16 players. So because order is not important, only people are important. So it means order is not important. This is a question of the combination. So look now, the number of the teams is 16C11. So 16 factorial over 16 minus 11 factorial into 11 factorial. Now 16 minus 11 will be 5 factorial. This 11 factorial and 16 factorials remain as it is. And finally, you will solve it on the calculator. That will give you the answer. So now I'm going to tell you a short method by using the calculator. So look now. Look at the screen. That is the requirement 16C11. A very lengthy procedure was adopted to reach the answer, that is 4368. So look now, on the calculator you can solve it directly. So 16C11. So first you will press 16. So here is 16. So look at the screen, 16 is written. Then C, that is combination, is required. So you will press shift button. So then at the division button you can see that there is NCR written. So you will press now division button. So at the screen you can see 16C is written now, and then 16C11. So now you will press 11. So on the screen you can see 16C11 is written, and now you will press equal button. That will give you the answer. So look at the screen, 4368. So now look at the screen, that is 4368. So this is the short method to reach the answer. Here is another question. A team of the 5 people, which must contain 3 men and 2 women, is chosen from 8 men and 7 women. How many different teams can be selected? So again, if you can see at the question carefully, order is unimportant, only people are important. So there are 8 men, out of which 3 men are to be selected, and there are 7 women, out of which 2 women are to be selected. So it means order is unimportant, only people are important. So it is a question of the combinations. So look now, 3 men are going to be selected from 8 men. So 8C3, that will make up the 3 men chosen from out of 8, and 2 women out of the 7 women. So 7C2. So this will be the number of the arrangements that can be chosen from 7 women, and 2 women will be choose. So now you will multiply these two values. So 8C3 into 7C2. Solve it on the calculator. You will get this answer. Here is another question. 5 cards are dealt without replacement from a standard pack of 52 cards. Find the probability that exactly 3 of the 5 cards are hearts. So concentrate yourself. Here is the thinking process. You have to practice again and again, because this is a really tough task to differentiate between permutation and combination. It needs a lot of hard work and practice. So here is the thinking process. So look now, the sample space is very large. It would consist of a list of the all possible sets of the 5 cards, which you could choose from the 52 cards in the pack. You do not need such a list. However, all you need to know is how many different sets of the cards the sample space contains. You are choosing 5 objects. So look now, 5 cards are dealt without replacement from a standard pack of the 52 playing cards. So the number of the unrestricted choices is 52C5, because the number of the selection is irrelevant. Okay. Further, it is required find the probability that the exactly 3 of the 5 cards are hearts. So in a standard pack of playing cards, you know there are 13 hearts. So it is required in the question that exactly 3 should be the hearts. So there are 13 cards of the hearts in the standard pack of playing cards. So it means 13C3 will be the number of the arrangements, number of the ways that 3 hearts can be chosen. So look now, let A be the event that exactly 3 cards of the 5 dealt out are hearts. The method used to find the number of the outcomes in the event is very similar. So look now, there are 13C3 teams of the 3 hearts. But in total, we are required to choose 5 playing cards, out of which exactly 3 should be the hearts. So that is actually chosen. Now, 2 cards will be chosen from the remaining 39 cards, because now 39 cards will be left in the standard pack of the playing cards. So now 39C2. There are so 39C2 teams of the 2 non-hearts. Therefore, the number of the sets of the 5 cards with exactly 3 hearts is 13C3 into 39C2. So now we are going to find the probability at last. So this is the favorable outcome, because 5 cards are to be chosen, out of which exactly 3 are hearts. So this factor will be put in the numerator, and the total number of the options will be put in the denominator, that is 52C5. Now you will solve it on the calculator to get the answer. Here is another question. So concentrate yourself. Question is, find the number of the ways of arranging 6 women and 3 men to stand in a row so that all 3 men are standing together. So concentrate yourself. Here is the thinking process first. You can make this problem simpler by thinking of the 3 men as a single unit, because they have to stand together. So think they are a single unit. So if they are a single unit, and other than the men there are 6 women, so in total they are considered as a 1 unit. So in total there are 7 units now. So look now, imagine tying them together. For example, you would then have 7 items or units, the 6 individual women and the block of the 3 men. So one possible arrangement would be, so woman 1, woman 2, 3, 4, 5, 6 women are there, and now in this order men are standing there, where W3 for example represent the 3rd woman. Okay, look now, the number of the permutations of these 7 units is 7 factorial. However, for each of these permutations, the men could be arranged inside the row in 3 factorial different ways, because the order of the men can be changed. So there are 3 men in a unit. So it means 3 factorial is the number of the ways that can be arranged 3 men in different orders. So it means 3 factorial. And in total, there were 7 units, including 3 men's block and 6 individual women. So that was 7 factorial. And the men can be arranged in 3 factorial ways. So 7 factorial into 3 factorial will give you the answer. Here is another question. So concentrate yourself. Find the number of the ways of arranging 6 women and 3 men in a row so that no 2 men are standing next to one another. So 6 women and 3 men are there, which are required to stand in a row, but no 2 men should be standing next to one another. So look now, here is the thinking process. You can ensure that no 2 men stand next to one another in the following way. Arrange the 6 women to stand in a line with a space between each pair of them and 2 extra spaces, one at each end of the line. So one such arrangement is here. So look now, here are 6 women. So W1, 2, 3, 4, 5, 6. So these are 6 women which are standing in a way that there is some space between the 2 women. So now there are 3 men here which are required to be stand in such a way that no 2 men will be standing next to one another. So look now, here are the spaces. So the number of the choices for the first man to be stand are, there are 7 choices, space 1, 2, 3, 4, 5, 6, 7. So once the 1 man will be standing there, there will be 6 spaces left for the second man, and then there will be 5 spaces left for the third man. So look now. Therefore, the number of the permutations in which no two men stand next to one another is, so 6 factorial is the number of the ways the woman can stand. Then 7 choices were there for the first man to stand, 6 choices were there for the second man to stand, and then 5 choices were there for the third man to stand. And when you will solve it, you will get this answer. Here is another question. So concentrate. A group of the 12 people consisting of 6 married couples is arranged and at random in a line for a photograph. Find the probability that each wife is standing next to her husband. So probability is the requirement. Probabilities formula is favorable outcomes over total outcomes. So look now, this is the thinking process. The number of the unrestricted arrangement is 12 factorial. So this is the total number of the outcomes. Now we are going to find the favorable outcomes in which every wife will be stand next to her husband. So it means now consider each wife and husband as a single unit. So if they are a single unit, so in total there will be 6 units. So it means 6 factorial will be the ways in which the 6 couples can be arranged. But also husband and wife can be arranged in a way that first husband, then wife, or there is another way, first wife, then husband. So it means there is 2 factorial way for every couple, and in total there are 6 couples. So it means 2 factorial raised to the power 6 ways are also there. So it means 6 couples, 6 factorial. And now for the arrangement of the couple, each couple is 2 factorial, and in total there are 6 couples. So 2 factorial raised to the power 6. So it means 6 factorial into 2 factorial raised to the power 6 is the favorable outcomes. So look now, 6 factorial into 2 factorial raised to the power 6 is the favorable outcomes, and 12 factorial is the total number of the outcomes. Now when you will solve it on the calculator, you will get the answer. Here is another very important question. So look now, 4 letters are to be selected from the letters in the word rigidity. How many different combinations are there? So look now, combinations, not permutation. If this was the question of the permutation, this will be much easier, but this is a question of the combination. So look now, the problem here is that the letters are not all distinct, they are identical letters. Since there are 3 I's, so therefore the answer is not 8C4, because identical letters are there, distinct letters are not there. So look now, first case will be combination with no I's. So in total there are 8 letters. So if there are no I, so the first case will be, then 5 letters will be left. So 5C4. When you will solve it on the calculator, this will be the answer. And here will be the case 2, combination with 1 I. So when 1 I will be chosen, so it means 3 letters will be chosen from out of these 5 letters. So look now, because total 4 letters are to be chosen, and the case 2 is combination with 1 I. So it means 3 letters will be chosen from here out of 5. So 5C3. So answer will be 2. Look now, case 3, combination with 2 I's, because now 2 I's will be selected. So it means we have to choose the remaining 2 letters from these 5 letters. So 5C2 will give you answer 10. And now last case is combination with 3 letters, 3 I's. So when 3 I's will have to be chosen, so 1 letter will be chosen from these 5 letters. So 5C1, answer will give you 5. So now you will add all 4 cases answer. So look now, 5 plus 10 plus 10 plus 5 will give you the answer 30. So all 30 combinations have been listed above. So this will be the answer. So this is a very important question, because this was a question of the combination. So this method will be adopted to solve it. So practice it a lot. So this was the lecture, students. So read this lecture again, understand it, practice it, and make your notes. Thank you so much.